Hello everybody, today we're taking a look at Unit 1, Systems of Linear Equations, using the elimination method. Our learning objective is I can set up and solve a system of linear equations using graphing, substitution, and elimination methods given real-world conditions. And more specifically, we're going to be doing just elimination. All right, so let's take a look at the problem here. So imagine you are a foreign exchange student coming to America for the first time. You've never seen our money and don't know how much the quarter, dime, nickel, and penny are worth. Your host family says they will give you $100 if you can figure out their values given the following clues. So we're going to have clue set 1 and clue set 2. So let's take a look at clue set 1. Clue set 1 says that 2 quarters and 3 dimes is worth 80 cents, and 4 quarters and 2 dimes is worth $1.20. So from these two clues, we're going to try to figure out how much a quarter is worth and how much a dime is worth. Just keeping in mind that we do not know how much they are worth, but we will confirm that they are worth 25 cents and 10 cents. So to set this up, we need to set up a system of linear equations. So I'm going to take a look at my first clue here. It says 2 quarters and 3 dimes is worth 80 cents. So let's actually get some money here that'll help us kind of see it. We'll say 2 quarters and 1, 2, 3 dimes is worth 80 cents, which is true. I mean, we have 50, 60, 70, 80 cents, right? But we don't know that these are 25 and 10 cents. But I wanted to put this out as kind of a visual aid to help write our systems of equations. So to write our equation here, I'm going to use variables Q and D for quarters and dimes. So if I wanted to set this up as an equation, I would say 2Q, because I have 2 quarters, plus 3 dimes, letter D there, that's equal to 0.80 cents, okay? So that is kind of taking this line, this clue right here, and putting it into a mathematical equation. All right, let's do the same thing for our second clue here. 4 quarters and 2 dimes is worth $1.20. So instead of 2 quarters, now we have 4 quarters and 2 dimes. That makes sense, right? 4 quarters, 2 dimes. Again, let's write a or a linear equation here. So we have 4 quarters plus 2 dimes equals $1.20. Okay? So that's how we go from the actual, just kind of the English language clue written here, like that, putting it into a mathematical representation. So let's get rid of these and keep going. Sometimes it's nice to kind of visualize or see the objects you're working with. So now we have to deal with these clues. 2Q plus 3D equals 80 cents, and 4Q plus 2D is $1.20. Now, how do we figure out how much a quarter is worth, how much a dime is worth? That is where we're going to use the elimination method. What the elimination method does is you eliminate one of our variables by creating something in common in both equations. So if I can set up one of my variables, have it be in common with the other, my other equation, then I can subtract these lines from each other and end up eliminating a variable. So it's probably easier to see what I'm trying to describe here. Now I notice I have 2Q and 3D, 4Q and 2D. None of those are the same, right? 2Q is not the same as 4Q, 3D is not the same as 2D. So I can't do anything to eliminate a variable yet. But there is a way to set this up so that there is something in common. And what I notice is that if I double this first line right here, if I times this everything in here by 2, then this 2Q is going to turn into a 4Q, which is the same as this line here. So, and that's kind of what we're trying to do. We want something to be in common. So what I'm going to do is I'm going to take this whole first line here, and I'm going to times it by 2. So I'm going to go 2 times that line. So I'm going to kind of draw a line here, and I'm going to do a little bit of work here. So I'm going to go 2 times this side of the equals, and whatever I do on one side of the equals, right, I'm taking this 2Q plus 3D, I'm timesing it by 2, so I better do that to the other side of the equals too, just to keep everything balanced. And I go 2 times my 80 cents, okay? Basically what I've done is, instead of 2 quarters and 3 dimes, now I'm going 4 quarters and 6 dimes, and then I'm going to double how much that's worth. All right, so let's take a look. 2 times 2, I'm going to distribute this, right? 2 times 2 is 4Q, plus 2 times 3 is 6D, equals 2 times 80 cents is $1.60. All right. So let's take a look and see if this is correct. We have 4 quarters, which makes $1, right? And 6 dimes, which makes 60 cents. So that does make $1.60. So this statement is absolutely true. Now we don't know that a quarter is 25 cents and dimes 10 cents, but we're trying to figure that out. But we do know that that is correct. Now what we can do, we doubled this line. We're going to keep this line exactly the same here. This one is identical because the 4Q is the same as the 4Q. So now we've written this equation. And we have something in common. We have 4Q in both of these equations. All right. And this is kind of the key point for elimination. Once you have something that's the same in both equations, then you use subtraction. So you subtract everything from this equation here minus this equation here. And you can actually, if you have all your variables lined up, your Q's lined up, your D's lined up, your numbers are lined up, you can actually subtract right down the line here if everything's lined up the right way. So 4Q minus 4Q, that's 0Q, that's nothing. So 0. 6D minus 2D is 4D. I'll put a plus sign there. So 4D is equal to $1.60 minus $1.20. That's 40 cents. So now I have 4D is equal to 40 cents. To get D by itself, I need to divide by 4. Divide by 4. 4's cancel. So a dime, is worth 10 cents. Ooh, that is right. Now, we don't really know that. Of course, we didn't know that a dime's worth 10 cents all along, but we just figured it out. Now we're going to take the fact that our dime's worth 10 cents, and we plug that into one of our original equations to figure out how much a quarter costs. So I'm just going to plug it into this original line here. So 2 quarters plus 3 times our dimes. Now a dime is now 10 cents. 3 times 10 cents equals 80 cents. All right. 2 quarters, we don't know what a quarter is yet, plus 3 times 10 cents is 30 cents equals 80 cents. Subtract the 30 cents from either side. Sorry, I'm running out of room here. Now we know that 2 quarters is equal to 80 cents minus 30 cents, which is 50 cents. Divide both sides by 2, and we will figure out that a quarter is worth 25 cents. So there you have it. There's how you show that a quarter is worth 25 cents and a dime is worth 10 cents, just given those clues there. All right, let's go to clue set 2. I'll try to stay on the page here. 4 nickels and 4 nickels and 2 pennies is worth 22 cents. There's our 4 nickels and our 2 pennies. So to write this in an equation form, I have 4 times my amount of nickels plus 2 times my amount of pennies is equal to 22 cents. All right. Second clue is 1 nickel and 3 pennies. So 1 nickel and 3 pennies. 1 nickel plus 3 pennies is 8 cents. 0.08. All right, so there's our 2 equations. Similar to before, we do not have anything in common here, right? The 4n is not the same as 1n. 2p not the same as 3p. We don't have anything in common, so we need to do something to one of these 2 lines of equations and to make something be in common. Now, I just see the 2 and the 3. I would have to find a common number like 6. I could multiply this by 3 and multiply this by 2, and then there'd be 6 pennies in each. But an easier way, since I have 1n, if I multiply this line by 4, then that will give me the 4n. So I'm going to take this line. I'm going to go 4 times bigger to that line, right? And I'm going to do that work right under here. So if I go 4 times, I'm going to change the 1n to just an n plus 3p equals. Now I'm going to do the same thing. I need to since I multiplied this side of the equals times 4, I need to multiply that times the equals times 4. So 4 times 0.08. All right. This is going to give me 4 nickels plus 12 pennies equals 4 times 8 is 32 cents, right? 0.32. And that's absolutely right. 4 nickels would be 20 cents plus 12 more is 32 cents. So this equation makes sense as well. All right. This can be considered like another clue. Now from here, we have the 4n plus 12p is 32 cents. Up here, we have 4n plus 2p is 22 cents. The 4n is in common now in both equations. So I'm going to use that 4n plus 2p equals 22 cents. Now I have 4n in both equations. I can eliminate that variable since they're in common. So when I use subtraction here, 4n minus 4n, that's 0, plus 12p minus 2p, this is 10p, so 10 pennies is equal to 32 cents minus 22 cents. So 10 pennies is equal to 10 cents. That makes sense. That's good. Divide by 10, divide by 10. So a penny is worth 0.01. That is 1 cent. Fantastic. Now, we need to figure out what the nickel is still. Let's use one of these original equations. So 1 nickel plus 3 pennies is 8 cents. That seems like an easy one. Bam, I'm going to use this equation right here, except plugging in 1 cent for my penny. So 1 nickel plus 3 pennies, and pennies worth 0.01 is equal to 0.08. That's 8 cents. Just my 1 nickel plus 3 times 0.01 is 3 cents, right? So 0.03 is 0.08. Oh, didn't need that there. Still don't have nickel by itself, so I need to subtract the 0.03, leaving me with a nickel is worth 0.05, which is 5 cents, right? Yes, very good. All right, so that's how we figure out the how much the value of each coin. Thank you. Bye-bye.